today we're going to be talking about ratios and proportions. So first of all, let's talk about what is a ratio. Okay, so a ratio is going to be a comparison of two numbers, and it can be written in a couple of different formats. So it could be written as one number over the other. It could be written as one number to the other with a colon in between. And either way that we write them, we mean to say that these two numbers have a special relationship, or we're comparing them, okay? And specifically, we're comparing them using division. So I know that some of you may not remember this, but the reason we can write fractions this way is because that line between the A and the B means that we are dividing those two numbers. That is a division line, okay? And so when we write them this way, they are fractions, okay? But they are also a ratio because they represent two quantities that we are comparing, okay, using division. When we put these together and we say, okay, that's great. I think that the ratio of girls to boys in Miss Dossie's class is the same ratio as girls to boys in Miss Smith's class, okay? Then we are creating a proportion. So a proportion is going to be two ratios that have an equal sign between them. So they are two equivalent proportions, all right? And so a proportion is going to be really, really helpful. When we're looking at proportions, we have a couple of different names here that we need to look at, or terms, I guess they would be called. And so first of all, the first and last terms here, okay, in this case A and D, these are called the extremes. Okay, so this is an extreme, and this one is an extreme. And you just need to learn this vocabulary. We'll talk about it more and what it means in class more. The two middle terms, in this case B and C, these are called the mean. Okay. And you probably already used these when you talked about ratios and proportions several years ago in math class. And instead of talking about extremes and means and cross products and things like that, you probably learned to cross multiply and divide. So you were probably given a proportion that looked something like this, and you were told that you wanted to multiply the two numbers that were across from each other. So that would be 10 times 50. And then you wanted to divide by whatever the other number that you were given was, in this case 25. Okay? What I want you to get used to doing is to know that if you will cross the numbers that are across from each other, so the two extremes and the two means, you are going to be able to set those up as being equal. So we're multiplying the numbers across from each other, and then those quantities we can set equal to each other. And here's why that's important. On here, we just have one variable, that nice lonely x. So we can multiply 10 times 50 and get 500. And we can do 25 times x, right? We can divide by 25. So guess what? All we've done so far is cross multiply and then divide by the number that was left over. Okay? And that's all fine and dandy. And we find out then that x equals 20. Great? That's great. However, sometimes, now that we're in high school and we're trying more challenging things, we are going to have algebraic expressions instead of just one variable. And those algebraic expressions could be in any of or all of the four locations here for the extremes and means. So let's take a look at one of those. Okay, so here we have 4x minus 5 over 3 is equal to negative 26 over 6. Okay, so we're still going to cross multiply. Okay, so I get 4x minus 5 times 6, and that's going to be equal to 3 times negative 26. Now notice here, there's no one lone variable all by itself. So we were not able to just multiply and divide straight in our calculator without writing anything down. We have some work we have to do. Also, I noticed that when we were doing some of our multiplying in our last chapter that some of us struggled with this. So it doesn't matter where this number is. If we have a number, a lone number, multiplied times an algebraic expression in a set of parentheses, you have to distribute, okay? So we're going to distribute this 6 through these parentheses. So we have 6 times 4 is 24, and 6 times 5 is 30, and that was a negative 5, so we have a negative 30. And then over on the right-hand side, on this problem, we don't have any algebraic expression, so we just multiply that, and we get 3 times 26 is negative 78, sorry, because that's a negative 26, all right? We're going to add 30 to both sides. I'm sorry, this 24 should have an x beside it. Almost made a silly mistake myself. So we have 24x left on the left-hand side, and negative 78 plus 30, and you're going to get 48, and that will be negative because the 78 was bigger. And then we are going to divide by 24 on both sides. Okay? And so in this case, our x is a negative 2. Okay? So I'm hoping that at this point you recognize you have to be sure that you are using this cross products property, where you actually write them all out when you have an algebraic expression there. Okay, that's going to be really important. We also will have some things called an extended ratio. Okay, extended ratio. And an extended ratio just means that we want to compare more than one thing. So maybe we want to compare blondes to brunettes to redheads in class. Okay? And so when we write them out sideways, okay, we have A, colon, B, colon, C, A to B to C. That's fine. When we want to turn that where it's one on top of the other, then you have to write out 2 different ratios. So we'd have A is to B and B is to C. And I'm sorry, I said 2. I meant 3. You'd also have, our third one, didn't leave much room, is A is to C. Okay, so you pick any 2 of those 3 and you write them as a stacked ratio. Okay, that's called an extended ratio. And again, that's usually used for things where there's more than one item to compare, or more than 2 items to compare. We're going to use those to compare triangles. Okay, so I might have a triangle here, and I might know that the angles, the ratio of the angles here, is 3 to 4 to 5. Okay. And I know that that's going to be an extended ratio because I have 3 different numbers there. Now, I don't know what each of those angles specifically is at the moment, and that's what I'm supposed to find. But I do know that whatever it is, I have to multiply all these by the same number, because otherwise they won't maintain this ratio. So I'm going to put an x beside each of them. Then, I also know that all the angles on a triangle add up to 180. So I'm going to do 3x plus 4x plus 5x equals 180. And I'm going to combine those, and I'm going to get 12x equals 180. And when I do 180 divided by 12, I'm going to find out that x equals 15. Okay. So that means that if I want each of those individual angle measurements, I have to multiply them, or plug x in place of the x that I labeled over here. So for example, 3x, that means this angle would be 3 times 15, so it is 45 degrees. This angle was 4x, which is 4 times 15, which is 60 degrees. And this one is 5x, which is 5 times 15, which is 75. So now I know the angle measurement of each of those angles of the triangle, and I wasn't given any information about the angles of the triangle. Okay? So we'll look at some other examples tomorrow, specifically dealing with the sides of some different polygons, and I really appreciate you watching this afternoon. Thank you. See you tomorrow.